Okay, so we always have to have the same denominator when we're working with fractions. That's what we're looking at. We're trying to find common denominator, which is the least common multiple of the denominators. So here, perform the operation. Look, it's already the same denominator. Yay, we don't have to do much work with that. Okay, so it's the same denominator, so I'm going to keep that in my answer and just subtract the numerators. And then can I go a little bit further with that? I can simplify 10 over 5, right? So 2 over x. That's it. Boom. Okay, here it's already a common denominator. That's also going to be the denominator in my answer. And then all I do is add the numerators. It's 3x plus 1. It is not 4x. Be careful. It's 3x plus 1. Yeah? Okay. Don't you want them all to be like that? Okay. All right, well, here we go. Find the least common multiple. Factor each completely. This is how you do it. Factor each completely. Then write the highest power of each factor. Wait, the highest power each factor occurs in either polynomial. So let me just show you what that means. So I'm going to factor this first one completely here. So what would I pull out of here? A 5. Can I go further with that? I can factor that further. What can I do? X plus 3, x minus 3. So I'm going to do that. Okay, that's the first one. That's factored completely. Now I'm going to do the next one. I'm going to pull out a 4. Okay, can I go further with that? Yeah, what would the factors of that trinomial be? You would be. X plus 3 times x plus 3, which is x plus 3 squared. Okay, now these directions say factor each completely, which I did. Then write the highest power of each factor occurs in either polynomial. Okay, so 5 and 4 are going to come down because they have the same power, so they're just part of the answer. You have to bring those down. But then you look at these factors and say, here's x plus 3 and here's x plus 3. This has a squared on it. So this is what I'm going to bring down. Okay, the highest power that each factor occurs. So x plus 3 squared is also part of the answer. This one doesn't have another one, but it's got to come down. Because it doesn't have another one, so that's got to come down. And then you just kind of make it pretty. There's only really one thing we can do here. What can we do? Okay, listen to the directions here. Write the highest power each factor occurs in either polynomial. So we have a polynomial here, and we had a polynomial here, right? So I had to bring the numbers down. They're part of the answer. But then I looked at the factors, and I say, here's an x plus 3, and here's an x plus 3. This one has a 2 on it. This is what comes down into the answer. Okay? It's sort of a process you kind of have to memorize. And then this doesn't have anything else, so that has to come down as well. If it had another one over here that, let's say, was x minus 3 cubed, that's what I would bring down. But since it's just by itself, it's got to come down. So you'd bring the x minus 3 cubed down to x plus 3 squared. Right. Okay. So now I'm just going to make it a little bit prettier. All I can do is multiply through the 20. 5 and 4. That's it. And then x plus 3 squared, x minus 3. That's all I can do. That's the least common multiple. If I were to try and find the common denominator for those two. I actually had a note to myself to start with this one because it's easier. This is probably the hardest one. But let's do the same thing. Factor each polynomial completely. Can I do anything to 5x cubed? Not really. I mean, I could split the x and x up, but I don't think I need to do that. Okay, so let's factor this one. What can I take out of each term here? A 5x, right? I can take a 5x out, and I get 2x minus 3. The 5 is in both. It's got to come down. Just one time, though. 5 is in both, it's got to come down just once. So if the same number is in both, just it comes down once. Then I look at the x. There's x cubed here and x here. So what comes down? And 2x minus 3. And that's it. Let's do another one. Okay, so we're going to factor this one first. What can I pull out of each of these? An 8. Oops, x minus 2. And then I'm going to factor this. Okay, so let's look at each term. Can I pull something out of each term? A 12. Let's do that first. And then can I factor that trinomial? Factors of -6 that add to +1. 3 and 2, right? +3 and -2. Okay, that's about as far as I can go. So let's start with the coefficients. You could just multiply them together, but what you really want to do when you have this kind of situation is find the least common multiple. And see, that's what happened up here with 5 and 4. The least common multiple is 20, isn't it? You see that? But here, it's not multiplying them together. What's the least common multiple of 8 and 12? 24. So that's what we're going to write down. 24. The least common multiple is 24. And then x minus 2 and x minus 2, they both have the same degree, so I'm just going to write it down once. And then I have x plus 3 as well, and that has to come down as well. So that's your answer. Should we let it absorb for a second? Now I have a common denominator. Now I can add the numerators. So I have 4x squared plus 3x minus 6 over 10x squared times x minus 2. Adding these, not multiplying, adding. So that's why it looks like that. You just have to practice it. It gets better. We're going to do more on the back. Are you ready? Ready or not? Here we go. Okay. So the same thing. I'm going to factor this. What can I pull out of here? A 3x. And I'm left with what? 3x minus 4. Okay? That I can also rewrite 3x squared as 3x times x. And I do that so I can get something common in each of my denominators. What do I have in common? 3x and the 3x. What is here that's not here? The x. So I'm going to multiply this fraction by x over x. And then what is here that's not here? So I'm going to multiply this by 3x minus 4. Top and bottom.
Wait, by 3x?
Yeah, because this denominator does not have the 3x minus 4. So I got to multiply.
I'm sorry, I thought you included both 3x.
Okay, so let's do that. So I have, in the top of this fraction, I have 3x minus 4 divided by 3x squared times 3x minus 4. Let's see where that takes us. Plus, you can make your life a little easier. When you get to this denominator here, you ultimately want to have the same thing here, 3x minus 4. So I'm going to multiply x by what's down here, and it just becomes 3x squared, 3x minus 4. X times that is 3x squared. That x times that part of the denominator. And then I have the same thing. Because it gets me to my common denominator. This and this are the same thing, aren't they? Yeah? Yeah. Okay. And now do I have common denominator? Yes. And so then I'm going to add this stuff together. It's add. So I put the x squared in the front to write the polynomial correctly. And that's all you can do with that one. This one's just like this. Do we need to do another one? Let's just set it up. Let's just set it up. Let's factor this. What would this factor to? What would this factor to? Times x plus 2, correct? Okay. And then what does this denominator factor to? X plus 2 and x minus 2. So they both have this, right? So, but I got to multiply this side by x minus 2. What do I have to multiply this fraction by? X plus 2. And then you would just do the multiplying out, get the common denominator, and add. Or subtract. This is a subtract. I didn't cross them off. I was just doing that to show that they have this in common. That's really all I was doing. Okay. I'll write it out for you. X minus 2 times x plus 1 is the numerator there. And then it would be on the denominator, it's x plus 2 squared times x minus 2. And then minus, because you still have both of these things and you have that. Still have both those things and you have that. Over here would be 6 times x plus 2 minus, or divided by, I have this x plus 2 and that x plus 2, which would be x plus 2 squared times x minus 2. Then I have a common denominator. Now I got to be tricky. That minus is a little tricky. So what you're going to do is you can distribute this negative. I'm just going to do the numerator right here. I'm just going to write out what I have in my numerator, because otherwise it's yucky. So I'm going to write x minus 2 times x plus 1 minus 6x minus 12. Do you see what I did there? That's my numerator. Because it's a minus. Minus 6x minus 12. I distributed that 6. And then I can make that numerator prettier by foiling, which is not fun, but we can do it. X squared minus x minus 2 minus 6x minus 12. It's still my numerator. I'm still just working with the numerator. I foiled these two. And then I combine like terms. And then I get, for my numerator, I get x squared minus 7x minus 14. And then my denominator is what I have up there. That's your answer. I know I did it all. I wasn't going to, but I did. Okay, we're going to start with this one down here. This is these are complex fractions because they have the fraction in the numerator and the denominator. Multiply the numerator and the denominator of each fraction by the LCD of both the numerator and the denominator. So let's start with this one here. If I look here and I look here, what's the common denominator? It's just x. The denominator in both of the numerator and the denominator is just x. So I'm going to multiply the top and the bottom by x. X over x. Okay, so I'm gonna write the numerator out here. I can just do this in my head, but I don't know if that I should be able to. I mean, I probably should show you how to do it. 2 over x minus 4. It looks like this, right? If I'm multiplying that numerator by x, that's kind of what it looks like, correct? Can you see that? Distributing that x, I'm going to get 2x over x minus 4x, correct? These cancel out. And my numerator becomes 2 minus 4x. That's my numerator. You could do it just by looking at it. Really, honestly, you can. So let's look at the denominator here. If I take x and multiply it by 2 over x, what am I going to be left with? Just a 2, correct? Well, no, I mean in this front part here. X times 2 over x leaves me with just 2. And then plus 3x, correct? So this just the denominator is 2 plus 3x. You can do that kind of in your head if you think about it. Or you can write out the process too. It doesn't matter. I just showed it to you and I didn't write it out. I just pointed it out. I said, okay, let's look at the bottom. If I do x times 2 over x, what do you mean? No. You just multiply the numerator by the least common multiple of these denominators, which is just x. So you're going to multiply the whole numerator by x and the whole denominator by x. Yeah, but look, if I do the denominator, it's this, right? And I'm going to multiply that whole thing by x. That's because if I distribute this x, it's like x over 1, right? When you're multiplying fractions? Right? Got it? Okay. All right, let's do one more. Let's look at this. What is the least common multiple of 6, 3, 5, and 10? Ooh. Bigger than that. Oh, no, we could do 30. We could do 30. Should we do 30? 30 is the least common multiple of 6, 3, 5, and 10. Very good. So 30 over 30. I'm going to multiply the numerator by 30 and the denominator by 30. So if I multiply this numerator by 30, let's just do it in our heads. We can do this. It's 30 over 1, basically, correct? I take 30, multiply by the numerator, which would be 30x, but I'm dividing by 6. So 30 divided by 6 is what? 5. So actually, my first term will be 5x in the numerator. Then I take 30 and multiply it by the second term. It's 30 times x divided by 3. What is that going to be? 30x divided by 3 is going to actually be what? 10x. So the numerator is 5x minus 10x. Then I do the denominator. 30 times x divided by 5 is actually going to be what? 30x over 5, which is actually what? 6x. 30 times 7, 210, divided by 10 is what? Minus 21. Okay? So can we make anything pretty here? Can we make that numerator prettier? We can subtract. They're like terms. So it's going to be negative 5x over 6x minus 21. I really should do this one, but I know you don't want to hear it. Okay, let's do it. All right. Least common multiple is going to be x times x minus 5. So I got to multiply the top and the bottom by x times x minus 5. That's the least common multiple. So I'm going to multiply the numerator. I'll do the numerator separate instead of just talking you through it. So it looks like this. The numerator is 6 over x minus 5. I'm going to multiply it by this right here over 1 minus 1 over x times x minus 5 over 1. It actually turns out kind of pretty. This goes away in this term, correct? And what do I have left in that term? Just 6x. This is my numerator still. I'm just working with the numerator. Here, what cancels out in this term? X. And what's left in my up here? Just x minus 5. That's my numerator. And then let's do the denominator. It's going to be 3 over x times x minus 5 over 1 minus 2 over x minus 5 times, I'm doing the denominator now. I'm doing this thing times that thing. This is an x minus 5. Now let's see what we can cancel. We can cancel the x's here. And we have in the denominator 3 times x minus 5 minus, we can cancel that. This really can be done. I swear it can be done all in your head. You could see it, but we're going to write it out first. And this becomes my denominator. So let's write this fraction, see what we have left over here. Here's my numerator, 6x minus x plus 5 over, I'm going to distribute this 3x minus 15 minus 2x, my denominator. And then you can make it pretty. 6x take away x is 5x plus 5 over, this just becomes x minus 15. That's a doozy. All right, I know that was a lot of fun.